Okay, I wanted to continue the examples of rationalizing the denominator and point out these specific properties here, that if we have the nth root of a fraction, we can actually separate that into the nth root of the numerator over the nth root of the denominator, and this is an equivalent form. Likewise, if we were to look at this in terms of the fractional exponent form of the root, then we're looking at the fraction a over b to the 1 over n power, which, if you remember your exponent rules, can be separated into a to the 1 over n power over b to the 1 over n power. And indeed, these two guys are the same. And I'm not really going to focus on this too much. I just wanted to point it out that this fractional representation, when it comes to exponents, is the same as the root form, and they follow the same rules and properties. So let me give you a few examples to illustrate these properties, starting with the square root of 1/9. Now, this I can simply separate into the square root of 1 over the square root of 9. The square root of 1 is 1, since 1 squared is equal to 1. That's a nice thing about 1, right? The square root of 9 is 3, and so this just comes out to 1/3. And you might have noticed that right away without even using this property. You might have said, oh yeah, 1/3 times 1/3 is 1/9. Therefore, the square root of 1/9 is 1/3. But if you didn't recognize that, that's okay. Use the property to separate it into the root of the top over the root of the bottom, and then take the root of each to obtain your simplified form. And so there's a nice example of using that property. Let me continue. How about the root of 7 over 20, let's say. So we'll take advantage of the same property. This gives me root 7 over root 20. And I guess I could rationalize the denominator from here. I could try to simplify that root 20. I think I'm going to go with that first choice. Let's go ahead and rationalize immediately. So this is root 20 on the bottom, root 20 on the top. And what that gives me is, let me continue in pink here, root 7 times root 20 all over 20. Now, we could multiply the 7 and the 20 and put that all under the same root, but I'm not going to do that because I want the simplified exact form in addition to this rationalized denominator case. So the root of 20 itself, remember that there is a perfect square factor in that, namely 4. So I could call this root 7 times root 4 times 5. There's my 20. All over 20 in the denominator. And recall, now I can take the root of this 4, I can separate it into the root of 4 times the root of 5. I'm just going to take that square root and say I've got a 2 and put that out front. 2 times root 7, I'm left with the root 5, all over 20. And now I'm going to do a couple things simultaneously. I am going to reduce this number, 2 on the outside to make it a 1, because 20 reduces by 2. Now that's a 10. And what I'm going to do simultaneously at the same time is multiply the 7 and the 5. So in the end, this becomes the root of 35 all over 10. There's my final result. Simplified exact form, as well as the denominator has been rationalized. Let me see if I have room for another one down here, and then I think I'll erase it and put a couple more. How about this one? Let's do a cube root. Okay, suppose I had the cube root of 8 over 27. Using the property above, I'm going to separate this into the cube root of 8 over the cube root of 27. And continuing, the cube root of 8 comes out really nice. It's a perfect cube. Comes out to 2. The cube root of 27 is also a perfect cube. Comes out to 3, and so we have our result there. That's simply 2/3. Nice when it comes out like that. You may have recognized that right away. 2/3 times 2/3 times 2/3 is 8/27. Therefore, the cube root of 8/27 is 2/3. But if you didn't recognize it right away, then please use the property and go from there. That's why I'm showing the property. So let me erase some of this and then show some additional examples. You can always rewind to look at that property. Rewind, just like a tape, right? I've still got a VCR in my house. What are you gonna do with all those tapes? Just get rid of them? Come on. All right. I don't have an 8-track for audio tapes. Not quite that old. Thankfully, you can't see all the gray hair in the videos. Not that high def. All right. Oh, you just turn down the lights. All kinds of features are hidden. And I feel like I'm straying from math, so I'm just going to leave that alone. And I hope you're having fun watching me erase the piece of glass here. This ginormous, thick piece of glass. That could kill you if it fell on you, I'm sure. All right. My goodness. I feel like I'm pushing so hard to erase this. You know why? Because I'm a math teacher. I don't shovel rocks for a living. I just mark on chalkboards and whiteboards and glass boards and all kinds of stuff. Okay. Let me go back to what we were talking about. That would be a really good thing at this point. And show some additional examples. Suppose we had the cube root of 5/8. Now we can exploit the same property that I mentioned previously and say that this is the cube root of 5 over the cube root of 8. The cube root of 8 is a perfect cube, so this comes out to the cube root of 5 over 2. And that is our quote-unquote simplified answer or result that shows the denominator being rationalized. Suppose we had the cube root of 5/7. So pretty similar, but now we're not having a perfect cube in the denominator. I can separate this as, again, the cube root of 5 over the cube root of 7. Now, if I want to rationalize the denominator, I have to be a little bit more careful than with the square roots. When I do it, okay, here's what I want to start with. Multiply by cube root of 7 over cube root of 7. However, I'm going to have to do it again because we're looking at a cube. Okay. So how does that make sense? If I did the cube root of 7 times the cube root of 7 times the cube root of 7, all this stuff down here, that comes out to the cube root of 7 times 7 times 7. Let me show that to continue to try to make sense out of this. On the top, cube root of 5 times cube root of 7 times cube root of 7. I'll just write it all together like this. In fact, I will put them all under the same house because we can combine them. Okay, and on the bottom I've got cube root of 7 times 7 times 7. And I think you're probably seeing why I had to do it a second time. And really, I'm just multiplying the fraction by 1 and times 1 again. But the reason why I had to do it is because I needed a 7 cubed down there. So that on the top, I've got 3 times. There's nothing I can simplify here, so it's simply 49 times 5. 49 times 5, 45, 4, 24. Okay, 245. It's kind of like an auction. cube root of 245 over, this one is the cube root of 7 cubed, which means the cube root of 7 cubed is just 7, and I have rationalized the denominator. So one more step just to finish that out. I've got the cube root of 245 over 7, and now I have rationalized the denominator. In the simplified exact form is what it's showing there, with the denominator rationalized. I think the simpler form is what you're looking at to begin with, the cube root of 5/7, but if your instruction is to rationalize the denominator, that's what it looks like. And there is more to talk about with rationalizing. We could rationalize denominators where we have a couple terms instead of just a single term to start with. But I'm not going to talk about that just yet, so stay tuned. That may come in later videos.